This is an Algebra 2 lesson on dividing polynomials using synthetic division. The objective for this lesson is students will divide polynomials using synthetic division. We will not be skipping degrees. So, we've learned about how to do long division, and we're going to learn synthetic division. So in long division, when you worked out this problem, you would first figure out what's the degree of the first polynomial. This is x to the third right here. So everything needs to be descending, so x squared, x to the first, and of course your constant at the end. So I'm going to work this out real quickly here. Setting up my division problem. And you should be familiar with how to do this already at this point. If you do not know long division yet, you need to go back into some of the older lessons I have on long division. And you'll notice you have a remainder of 10. Now, I just did that. It took me over a minute to do that, and I'm really good at doing this too, so it takes a while. So in synthetic division, it's a little bit differently. When we could use synthetic division whenever our divisor is in the form of x plus a, or x minus a. X minus a. Now, over here it says x plus 1. That doesn't work, but we know that x plus 1 could be rewritten as x minus negative 1. Right? So our a is really negative 1 in this instant. But let's pretend for a moment other examples. If it was x minus 1, we know a would be equal to 1. Or let's say it was t minus 9 as your divisor, we know that a would be equal to 9. Or if it said t plus 9, then we know a is equal to negative 9 because we know that t plus 9 is like saying t minus a negative 9. That's just the format it needs to be in, but you should know that before you start working synthetic division. So, we know that a is equal to negative 1. So we've identified that. Then on your first polynomial, you want to make sure that you have all of your coefficients in order. So we already do here. Identify all your coefficients. So our first coefficient is 3, so we bring a 3 down. Okay, then it's a negative 4. It's right here. And then we have a positive 2 and a negative 1. Those are all your coefficients. Then you write down your a. Adjacent to it, write down negative 1 and put like a kind of like a half box around it. Okay? And leave a little space for numbers to write over here, so leave some space and draw a line underneath. And now you set up your synthetic division problem. From this point on, it's pretty straightforward. So you just bring down your first coefficient of 3 and bring it down. Then you multiply 3 times negative 1. 3 times negative 1 is negative 3. You put the answer right here. Okay, and then you add. Negative 4 plus negative 3 is negative 7. And then we multiply again. Negative 7 times negative 1 is going to be positive 7. We add again. 2 plus 7 is 9. And multiply again. 9 times negative 1. 9 times negative 1 is negative 9. Add again, and you get negative 10. Now, at this point, this is the end of the synthetic division problem. So you should be able to see a correlation here. If you look at all of these numbers here that we just got, actually that's a little too big here. Those numbers, you're going to notice that these numbers are the same coefficients as the ones down there, and that your remainder is positive 10 or negative 10. Okay? So, since that's the case, and by the way, this is supposed to be a negative 10 here. I'm not sure why I put positive 10. Negative 10. You're going to notice that those are all of your coefficients. So since that's the case, you didn't really need to write out all the x squareds, x cubes, and everything. So now we have to write our answer in standard form. So since 3 is our first coefficient, we would start with, we figure out what the initial degree was, and the initial degree, if you look up here, is x cubed. So take the next degree that's down from there, which is x squared. So start by writing 3. X squared minus next degree, 7x to the first, or just 7x plus 9, okay? And then we subtract it. Now 9 is our constant, so the next term has to be a remainder, because there's the only thing that's next is a remainder, so it's negative 10 over our divisor, which was x plus 1. Okay? And then, of course, you box your answer, and you are done with number 1. Okay? So let's try some more here. Continuing on. Example number... Oh, before that. So a couple points. When you set up your synthetic division problem, you want to first identify your coefficients in descending order. And then you want to also identify the constant term in a in your divisor in terms of x minus a. If you get those two things down, this is going to be a piece of cake for you. So let's look at example 2 now. Okay? Example 2. These examples are, of course, are going to be in descending order because this is the first time you're dealing with it. Okay? First thing you want to do, figure out your coefficients. So there's a coefficient of positive 1 here, coefficient of negative 4. There's a coefficient of positive 1 here, and a coefficient, and then the constant's negative 6. So you take all these coefficients in that order. So you write 1, negative 4, positive 1, negative 6. And then you find what a is. Now a, remember, it's supposed to be in the form of x minus a. Okay, so a in this example is not going to be positive 1. It's going to be, you have to rewrite this divisor as x minus a negative 1. So your a is negative 1. Okay, so you're going to write that over here on the side. It's not always going to be negative 1. In these last two examples, it was negative 1, but it's not always going to be negative 1. So draw your line, leaving a little space to write. Bring down your 1 first. 1 times negative 1 is negative 1. Add negative 4 plus negative 1 is negative 5. Multiply negative 5 times negative 1 is positive 5. Add 1 plus 5 is 6. 6 times negative 1 is negative 6. Add, you get negative 12. Okay, so it looks like we have a remainder here again. So looking originally at our problem, it was originally in the third degree, so you're going to start with the next degree lower, which is x squared. So you're going to go 1x squared, and of course, since it's a 1, you don't need to put a 1 in the front. We assume that it's a 1. Minus 5x to the first power, which is 5x, plus 6 minus 12 over x plus 1. Okay, and that's how you do this example. So this one has a remainder also. Third example here. Okay, this one has a different divisor. Our a here, you can see, it says x plus 2, so your a is going to be 1. A is going to be negative 2. Okay, and then looking at your coefficients, we have a 1 here, negative 2, negative 5, positive 6. So we write these down: 1, negative 2, negative 5, positive 6, and our a here is negative 2, negative 2. Okay, so first thing you need to do is draw a line, leave a little space, bring down the 1 first. 1 down here. 1 times negative 2 is negative 2. Add them together, you get negative 4. 4 times negative 2 is negative 8. 4 times negative 2 is positive 8. Going too fast there. Negative 5 plus 8 is positive 3. Then we have positive 3 times negative 2 is negative 6. 6 plus negative 6 is 0. Now, we could predict that since there's a 0 here, that we know that there's no remainder. So our answer came out pretty perfectly here, right? So, again, we know that our largest degree is our largest exponent is to the third power, so it's a polynomial to the third degree. So it's going to be x squared, you take the next one smaller, minus 4x plus 3 is your answer. Okay? There's no remainder, so we don't need to worry about that 0 that's left there. So synthetic division is pretty easy. Remember, you are, on each step, you are adding first, so it's 1 plus 0 is 1. Multiply 1 times the a with -2, put the answer there, and then add again going downwards, you get -4, and so forth, and you keep going down, up and down, or diagonal and down on each of these until you get to the end, and then you rewrite your answer in standard form. That concludes the lesson on synthetic division.